now it's like, whoa.
Hello guys, welcome back to our YouTube channel Algorithm Pod. My name is Jitesh. So here I am with a new video of cryptography and network security. So in this video we are going to discuss DES algorithm, one of the block cipher algorithms. So DES stands for Data Encryption Standard, DES. So it is basically a block cipher algorithm which does the encryption process in the series of rounds. So it has a total of 16 rounds, and the text size, which means the input plain text size is of 64 bits, and the key size is 48 bits. Now you might be wondering why the text size is 64 and key size is 48. It should be, key size and text size should be nearly the same. You might be wondering that. Now we are taking 8 bits for parity. Parity means maintaining a check. These are series of bits which are used to maintain the check, like a reference point or a bookmark, something like that. Then rearrangement bits are the ones which are removed after performing some permutations in the sense selecting and arranging, like that. So this is the block diagram for the DES algorithm. At the end, what is our main goal is to convert plain text to ciphertext. How exactly this happens? So we have our, think of it like a machine. So this is your input and this is the output. Now this, think of this as a machine, DES. Now this machine takes the plain text and it performs some initial permutations on it. Initial permutations can be anything like rearranging the bits, something like that. Now after the initial permutation, this plain text goes to the series of rounds. So we have total of 16 rounds, and each round uses a different key which is produced by a round key generator. Each plain text uses a different key which will be produced by a round key generator. How this round key generator works, I will explain in later part of the video. After undergoing this series of round, after completing the last round, final permutation is applied. So we have two things over here apart from rounds, that is initial permutation and final permutation. Permutation simply means arranging and selecting and rearranging the bits. After the final permutation only, we have to obtain the ciphertext. Now I will explain how this round key generator works, how the key generation is done at each round. Now the initial key size, as I said, the initial key size is same as the plain text. Now we are applying some permutation. Why we need to apply some permutation? To remove the parity bits. Parity bits are those bits which are embedded like a check bits basically. So it is total 64, right? So 8 by 8 matlab means 8 bits each. 8 bits block, it has block of 8 bits each. So we are removing these 8 bits, the end part of the block. So after that, the key size is of 56 bits. It is split into two blocks, each block of 28 bits. Now let's take this first half as A naught and the second as B naught. Now we need to apply the left circular shift. It is similar to the shift operations performed in the bitwise operator, but it performs in a circular manner. After performing this left circular shift, we obtain A1 and B1, which will be 28 and 28 bits each. Now then we are applying permutation again. Then we are combining these two, and we are applying a permutation, and basically what we are doing here is we are rearranging things. I have said here parity we have to remove 8 bits, and for rearrangement we have to remove 8 bits, which means we have selected the 48 bits which are be suitable to act as a key. Now this key is passed to the end of the round. This key after the round generation is passed to the rounds, and after each round encryption is performed. And since we are using different keys at each round, the complexity it also produces the avalanche effect. These are the some properties of block cipher, like avalanche effect and completeness in the sense each bit of ciphertext depends on many bits of plain text. One ciphertext is depending upon many bits of plain text, like that, one to many relationship. Avalanche effect in the sense at each uh, round, start from end, from starting to the ending, the complexity is increasing. The more complex it is, the more difficult it will become for attacker to crack the message. So that's it guys for this video. Thank you so much for watching this video. Make sure to like the video, subscribe to our YouTube channel Algorithm Pod, hit the bell icon for future notifications. That's it for this video. Thank you guys.